How about that first part one of our mini lesson there? Other things that topics we'll look at is why non-wood bats perform better than outperform wood bats, and this is coming from a great source. He used to be the chair of our department, Dr. Kruger, and then he was an associate dean, and now he is the full dean of arts and sciences. And we lost him to South Dakota State, but anyway, he was the science advisor for Little League, for the National Little League Baseball. And I told him, being a baseball purist, I told him, aluminum bats are useless. And he's like, no, actually, aluminum bats make it much more fun for everybody to play baseball because what with wood bats, the kind of the non-athletic kid might get a hit, but he'll dribble one back to the pitcher. But with an aluminum bat, he can probably, he or she can actually probably get a hit. Those types of things. So that's some of the things we might get around to looking at that. Why golf balls are dimpled? That's a good one. Perturbations, and all that kind of stuff. How high a pole vaulter can go, and how that dramatically changed with the fiberglass and now the nanofiber pole vaults. And we'll look at some of the pole vaulting. The Fosbury, different jumping styles. Okay, the Fosbury flop. This is Fosbury. He was an physics and engineering student at Oregon State, University of Oregon, which is a great track and field school. I mean, Oregon track and field is the same. You'd say in the same breath as UCLA basketball or North Carolina basketball, that kind of thing. Martial arts, throws and I don't do this so much. This was my boss, the Dr. Kruger I talked about. He was big into martial arts. I'm not so much. I'm a team sport kind of guy. I'm kind of, in the Marines, I was into hand-to-gland, and that's about it. So, all right, why boomerangs come back, and I'll show you, and I'll give you a little thing where you can go home and make a boomerang too if you feel like it, and especially if you have like little younger nieces and nephews or something like that, or little brothers and sisters, or some of you might even have kids that will get a kick out of it. Sports you might be interested in. Okay, so now what we're going to do over the next few minutes is talk about units. Okay, see, we're on slide 6. I'm trying to get down to about slide 14. All right, so we're moving along. Knowing about units is important. In physics, what we do in physics is we study nature. This is we make observations of how nature's working and take measurements so that we can make predictions later on. All right, that's what physics is. That's essentially what physics is: making observations, taking a measurement, and then being able to make predictions. So yeah, if somebody told you it's 25 degrees outside, if you were from the United States or from the Midwest, you go, oh, that's kind of chilly. That's below freezing. If you're from Europe or the Middle East or Asia, anywhere like that, if you're from Vietnam, or Kuwait, 2 countries I've been to, they'd say, oh, that's very pleasant. Because I remember driving past the Kuwaiti National Bank and seeing the just like on all banks, they had the temperature showing, and it said 44 degrees. Well, I was sweating through my flak jacket, so I know it was a lot warmer than 44 degrees Fahrenheit, and it was actually in centigrade. So here's the differences. And we'll do some of those temperature conversions too. That'll be part of your mini lesson too. That'll be fun. And it's easy to do. The coldest place so far in getting warmer, unfortunately. And in SI units, we use Celsius, the Celsius scale or the centigrade scale. It's the same thing. All right. For forces, we use newtons. Okay. Force is newtons. You're used to pounds. How many pounds of force was there? And then that gets us into the whole thing about mass, which is in kilograms, and pounds are not the same thing. Kilograms and pounds are very, very different. All right? But measure force, we use newtons. And to measure mass, which is how we measure, something doesn't want to move. It's got a lot of inertia. We don't say it's really heavy. It's got a lot of inertia. It just does not want to move. We measure that. That's the kilogram. This guy, lots of inertia. Very difficult to get him to move. Excuse me. This little kid, not much inertia at all. However, the forces that they're applying to each other right now are equal and opposite. Are the same, but in opposite directions. All right? And then we'll take a look at this, what it means to be weightless. Okay? Kilogram is not a measure of weight. Weight is a measure of your mass times the acceleration due to gravity. And I'll write that down in a note. But we're going to take a break here because I've got to go to a meeting that I'm already late for. So out here with part